Now hydrolysis. Hydro means water, so which means that if I add water. So you have learned before that acid and base give salt and water. So if I say acid plus base gives salt plus water. The opposite of this would be hydrolysis. If I add water to the salt, it's going to give me its parent acid and the base. Parent acid and the base. Parent acid and the base means from which it was made. Supposing I say the salt is Na2SO4. You will change this into a base, which is NaOH, and you will change this into an acid, H2SO4. So you will say it is made out of NaOH and sulfuric acid. And this is a salt of a strong base and a strong acid. Now look at this. What is going to happen when I hydrolyze a salt? First category is salt of a weak acid and a strong base. So CH3COONA is a salt made out of NaOH and acetic acid. Acetic acid is a weak acid, NaOH is a strong base. So weak acid and a strong base. So this dissociates into CH3COO minus and Na plus ions. Water changes into H ions and OH minus ions. Now when these combine, positive, negative, these two combine and form acetic acid. But NaOH is formed, but you know NaOH is completely dissociated. It is a strong electrolyte, divides again completely into ions. So that means Na ions and OH minus ions again split into them. NaOH is formed, but it is going to change into ions. So finally, I'll get sodium acetate reacts with water, CH3CONA plus water, gives you acetic acid plus Na ions and OH minus ions. Now inside the solution there are more OH minus ions, which means that there is going to be an alkaline solution. So solution becomes alkaline because this is a weak acid. The strong base has completely divided, changing into an alkaline solution. The same thing is also known as anionic hydrolysis. This is an anion. Negative ions are anions. Anion has combined with water, H plus ions of water, to form acetic acid. So hydrolysis has taken place at anionic position. The cation has split into its own ions. That means hydrolysis has not taken place. So, so in case of a weak acid and a strong base, anionic hydrolysis takes place. Solution becomes alkaline in nature. Look at the second situation where it is a salt of a weak base and a strong acid. Weak base and a strong acid means that if I am looking at NH4Cl, it is made from NH4OH base and HCl is the acid. So acid is strong and base is weak. So this is a salt of a weak base and a strong acid. So ammonium chloride divides into ammonium ions and chloride ions. Water divides into H ions and OH minus ions. Out of them, this is positive, this is negative. They combine and form ammonium hydroxide. HCl will be formed, but again HCl is a strong acid, so it's going to again divide into H ions and Cl minus ions, completely dissociate. So what I get in the end is, if ammonium chloride reacts with water, it gives ammonium hydroxide and H ions and Cl minus ions remain there as such. Now since there is excess of H plus ions in this solution, so solution becomes acidic. And this is called cationic hydrolysis because the cation has combined with OH of water. So hydrolysis has taken place at this end and has not taken place at this end. These ions are as such inside the solution. So we call this as cationic hydrolysis. Now third category could be salt of a weak acid and a weak base. So if I take, say, ammonium acetate, this is ammonium acetate, it gives acetate ions and ammonium ion. Water gives H ions and OH minus ions. So now out of them, Acetate ions combine with H ions to form acetic acid. Ammonium ions combine with OH minus ions to form ammonium hydroxide. So complete hydrolysis is taking place. Anion is combining, cation is combining, weak acid and a weak base is formed. So we say complete hydrolysis takes place. If Ka is equal to Kb, that means both of them have equal strength, then the solution will be neutral. If there is some variation in their strength, then solution can be acidic, it can be basic also, depending upon what type of acid and a base is formed at the end of the reaction. If I take the other category, which is salt of a strong acid and a strong base. So NaCl is made from NaOH, HCl. So NaOH is a strong base, HCl is a strong acid. So NaCl gives Na ions and Cl minus ions. Water is giving this. Now NaOH can be formed, HCl can be formed. But both of them are very, very strong. So they finally change into their ions as soon as they are put in water. We have learned this. Strong acids completely dissociate. Strong bases completely dissociate. So Na ions and OH minus ions remain there. H ions and Cl minus ions remain there. So strong base, strong acid. None of them have combined properly with water. They are still in the form of ions. So we'll say no hydrolysis takes place and the solution is now totally neutral. So if you are asked what type of a solution will this substance form? Supposing now I ask you that what type of a solution will be formed if I take, say, ferric chloride, FeCl3. So you will think that this is made from ferric hydroxide, which is the base, made from an acid HCl. Now say this is a weak base, but this is a strong acid. So this solution is going to be acidic in nature. If I say the salt is Na2CO3, now think that this is a base, which is NaOH, and this is an acid H2CO3 carbonic acid. So NaOH again is a strong base, carbonic acid is a weak acid. Whichever is strong is going to show its nature. So I'll say this solution is alkaline. So you may be directly asked this, what is going to happen? Which type of hydrolysis takes place? Show how hydrolysis takes place. Then you are going to write all this. If it just says explain why ferric chloride solution is acidic in nature, you will say it is a salt made from a weak base and a strong acid. And strong acid does not undergo hydrolysis, gives large concentration of H plus ions in the solution. That is why ferric chloride becomes acidic in nature. Where there is an alkaline solution, there are OH minus ions. Where there is an acidic solution, there are H plus ions.